Hello, ladies and gentlemen, and I'm happy to welcome you on our today's webinar. Uh, could you please confirm that you can hear me, please? Okay, thanks, Nick. Just a couple minutes, gentlemen. Let's wait for the guys who are being late, and at the end of this session, I'll answer all the questions I can handle, if you can say so. So just 2 minutes and we'll get started. Thanks. So off we go. So again, gentlemen, thank you for attending our today's webinar. And the theme of our webinar is actually how you can ensure high data availability with StarWind Virtual SAN and how actually to build a tiered storage. So my name is Alex Bajkowski and I'm your today host. So today we will discuss how to build automated tiered storage in StarWind Virtual SAN infrastructure. In addition, we'll discuss benefits of such setup. And of course, don't forget to ask questions and we'll cover them either today or in our next meetings. So here's our today agenda. First of all, we'll discuss why actually tiered storage can be used. Afterwards, we will discuss how you can combine StarWind Virtual SAN and tiered storage spaces. Afterwards, I will show you a little demo. And of course, at the end, we'll have a little Q&A session. So actually, why tiered storage? First of all, let's say that tiered storage consists of multiple tiers. That's obvious. Those tiers are divided in caching tier, performance tier, and capacity tier. Each as caching tier, usually that's SSD or NVMe storage. That's plays the role over there. For performance tier, that's as well flash. And for the capacity tier, it could be either SSDs or HDDs. It depends on your setup. So why should you use the tiered storage? First of all, one of the goals over here is to improve performance of legacy storage arrays. So for example, you have a lot of slow HDDs. You want to improve their speed or overall performance without without paying huge costs. So you can get some SSDs, some technology, for example, storage spaces, build tiered pool, and here we go. Your setup, your overall storage performance, storage IOPS will be increased. On the other hand, for example, you have a lot of SSDs. However, the resources of those SSDs are not utilized by your applications. your SSDs have much more performance. In this case, for example, you just can spread your SSDs or sell some, for example, add some HDDs to just to have more efficient utilization of your flash array, and in addition, you will have more storage capacity. And at the end of this, you can reduce the implementation cost of the actual storage solution. So let's discuss how you can combine StarWind Virtual SAN infrastructure and storage spaces. So on this diagram, you can see our basic setup: 2-node cluster. Today I will show I will show you 2-node Hyper-V cluster. In this each node of the cluster has some SSDs and HDDs installed. Those drives are from those drives. I've created a tiered pool with SSDs and HDDs. SSDs are added to SSDs are in mirrored pool and HDDs are in parity pool. So each tiered pool can lose, in my example, one SSD and one HDD and still handle this very properly. And of course, I will show you that as well. And on top of each pool of each server, we've created StarWind device and replicated it across the network. So that's why we have over here synchronization network, and that's for StarWind traffic for our replication. And as usual, as you may know, if you've ever worked with StarWind, we have a iSCSI network dedicated for iSCSI traffic between the nodes. So that's one of the possible configuration, and let's proceed and jump to the live demo part. Okay, let me bring the nodes. So just a second. Here we go. I have actually prepared a demo environment. That's 2 virtual machines. They're not pretty huge. However, that's enough for me to show you the demo part. Sorry, wrong window. Here we go. That's server number 2. As you can see, that's StarWind. So, a little review. So we have 2 nodes. That's our cluster. Oops. 2-node SW, SED, TSW01 and O2. And I've created a cluster on top of them. They are pretty small. I see 2 CPUs are added to each 2-core. Only 2 cores over here, 8 GB of RAM, and that's pretty it. Let's jump to the storage port. Two 500 gig SSDs and 3 HDDs, as I've told you. The SSDs are added to a mirrored pool, and HDDs are added to a parity pool. And that's our tiered storage created over here. So that's it is. On top of we have a drive E created. The capacity of the drive is 140 gig. On top of this volume, I've created StarWind devices needed for a cluster to work properly. 1 witness drive and 1 cluster shared volume, which I've created next. Then voila, created them in iSCSI initiator, of course, and here we go. 1 drive, 1 GB drive over here, an actual cluster shared volume. To have our test be our test more real, I've created a small Linux VM, that's Ubuntu, installed over here. It's working. I was doing some stuff over here as well. Midnight Commander is opened, so I can move it across the nodes. Everything works as it should. Great. In addition, let's take another look. So at this performance monitor, I prepared some counters, interesting counters to look at, actually how tiered storage work. So over here, the pool, the we have 100 of 500 gigabytes totally SSD drive, and in this pool, I think the actually SSD part is even smaller. And what I wanted to show you, that when we're having a working set small enough, actually only SSD pool is working. On the other hand, when we have our working set big enough, in this test it will be around 100 gig, both pools are working, both tiers are working, SSD and HDD. That's another part. Let's proceed with it. So actually, I'm using Microsoft Disk SPD tool. Okay, here we go. So I've prepared a short script. Basically, that's our cluster storage. That's our CSV on top of storage spaces, on top of StarWind. Oh, that's some kind of sandwich, as I like to call it. However, it works and works really good. So I will be testing our cluster shared volume with small random blocks, 4K, 100% write, 2 threads, 64 outstanding I/O, and we'll be testing it for 10 seconds just to show you how it works. And the file to start with will be only 10 gigabytes. Let me just find that's my batch file, which is over here. That's it's opened. Let's start. So click enter. Let's jump in over here. As you can see, so that's only SSD tier is working with some. Oh, it's already ended the test. Yep. Oh, that was some jumps. Where, as you can see, only SSD tier has been working. We actually can see some kind of performance. I think over here we'll see some, yeah. As if we look at CPU, since I have really small virtual machines, we'll see that CPU will be picked. So CPU resources will be picked. Thus, we couldn't get really much IOPS from this setup. However, if I will increase the size of the test file to 100 gig, we will receive even smaller results. Let's test it. Here you can see that both tiers are getting the IOPS, getting the workload, and the total IOPS will be even more than half smaller than we've received before. Yep, 1000 IOPS over here. So basically, that's how it works, and that's what I wanted to tell you. When you're planning tiered storage solution, either it would be with StarWind Virtual SAN or not, you should always understand the size of your working set. And if I found a good phrase on one of the Microsoft blogs, just a second. So if the working set size for the workloads is comparable to the size of your SSD tier, you should expect around 70% of your SSD tier performance at all. 70% or higher. If the reads or writes are more than your working set, then you will receive 50% and lower. It depends on the how bigger is your working set is comparing to your SSD tier. Okay, let's proceed and do another great thing I loved. So, as I've told you at the start of our demo, that's two virtual machines. Actually, one of them. So that's the nested cluster. These two are virtual machines. And let me just get one of the disks, delete out one of the disks from the VM. I'll do that on my other monitor, and you will see it in the server manager that we'll see an alarm over there. So let's start, and I will delete one SSD. I will leave the SSD on the leave the VMDK on the data source, so we can add it in the future fast. So to restore pool as fast as we can. Anyway, let's. I've just removed it, and yep, okay. Just a couple seconds. Oh, yeah, we can see an alarm. Oh yeah, I love Server Manager and PowerShell as well. It's sometimes giving weird output. Anyway, let's just open it. Server Manager one more time. Refreshing the data. Anyway, while we shouldn't be able to see the disk. Okay. Our cluster storage is still here. Our virtual machine as well is still here. Thus, the actual the disk which was removed out of the virtual machine didn't cause any problem. Okay. Oop. That's our E drive. That's one healthy. And that was healthy as well. Okay. That's some PowerShell steps. Oops. Storage. Oh. Interesting. Anyway, let me bring the disk back. That was interesting. I'm adding the existing disk. Let me actually check the output on the second node. Yeah, sometimes PowerShell giving us interesting outputs. Anyway, without even one disk, we're still working. That's what storage spaces and StarWind gives us. Redundancy and fault tolerance that is being achieved. Redundancy we achieve over here with storage spaces, and fault tolerance, that's what StarWind helps you and does for you. And still the volume is here, and the cluster storage is still here as well. So the next step which I wanted to show is that actually in this setup as well is usually what you usually want is the proper failover. Let's just our disk come back properly, and I will just reset node number 1 and do a hard reset, and we'll see, or number 2, and where actually our VM is located on the node 2. We'll reset node 2 and see the failover of the virtual machine. Let's synchronize node. Oh, I'm sorry. Yep, I muted myself. Let's just couple. So as you've seen, StarWind can handle the fail of one and disk from each pool, and this actual setup, and it still works and works good. And now I can let me just show you the cluster is still up, running, virtual machine as well running. I've actually brought the disk back up. Our volume is still healthy, so everything is great. Right now, if you don't mind, we'll jump to a questions and answers session, and I'll be pleased to answer all questions. So the first question was from Roger at the beginning. It's about a two-node setup when one of the nodes has 4 terabytes and the other has 8 terabytes. The total amount of the replicated storage, maximum replicated storage you can have is 4 terabytes. Yes, that's right. Additional 8 terabytes additional 4 terabytes left on the other node could be used as just standalone storage, and it can be shared as via iSCSI. Okay, the next question from Nick is, if a node is taken down for maintenance, can the VMs be moved beforehand to ensure no HA takes place? Uptime is very important. Of course, before maintenance, you can just move node in the failover cluster. I can actually show you how it's being done. Just failover cluster. Just let me do a quick show for you. Connect to the VM. It's working. Let's move it to the node 1. That's actually the best possible node over here. So you will see a quick blip, and it's still working. So that's you will do that for all VMs you have in your production, and just power off the node for the maintenance. Can this be implemented with Hyper-V Server 2016 standalone role? Could you please be a little? You mean just the Hyper-V Server 3? Yep. Let me just check. I don't remember. While I'm checking, let me answer your other question. So the question is from Issa. If 10G base T good for synchronization between the nodes? It depends on your actual workload. For example, with a RAID 10 with all 10K HDDs, for example, HDDs 10K RPM, the 10G base T will be more than enough for this workload. Another question. In tiered storage SSD cache, does they need to be RAID? No, they don't need actually to be RAID. All the drives you need an HBA. So the OS see each drive as separate. So as you can see over here, the bus is SAS. For example, if you have Dell servers, you can configure each drive as non-RAID. Thus, the OS will see the drives, will see the media type, and can work with the drive as a separate one. So over here, your pool or your RAID, if you can say so, that would be a software RAID that plays storage spaces plays that role. Okay, and what is the best recommended? Actually, over here, if you're planning a tiered storage with storage spaces and StarWind, it is recommended to have an HBA or enterprise level RAID controller and bypass the drives to the OS and let the storage spaces handle everything. Another question from Nick is, when maintenance occurs on a host, does the entire StarWind VM resyncs or just the delta? So over here, that's the VMs just to show you. Actually, you will build this solution that will be a Hyper-V failover cluster on servers, and that's where StarWind runs natively on Windows. Thus, when you will have maintenance for your host, the synchronization only will happen the delta if you shut down your host properly, so the only delta between hosts will be synchronized. In addition, we have a great feature called maintenance mode. So before the maintenance, you can put your highly available device into the maintenance mode to avoid full synchronization afterwards. That's another great thing. Okay, gentlemen. How is the Linux appliance coming along? We're actually preparing V2 of the Linux appliance. However, I don't actually have any ETAs right now, but I know that we're working hard on it, and it should be available as soon as possible. Well, let me check one thing. Maybe you have additional questions, gentlemen? Just checking about the Hyper-V server. Uh, that's actually a good question. You can email me. I will double check that because I've never actually checked that on the Hyper-V server. Thus, you can email me and I'll answer, and I'll do my best to answer you the question. You can find an email at the end of the presentation. Let me just. You can find my email over here. Okay, so another thing you're planning, it says planning have Dell R730 with 10 15K RPM SAS with RAID 6. I would recommend you actually going with RAID 10 to have the best performance. That's like we actually with HDD drives we recommend avoiding parity RAID arrays and go with RAID 10. to have the best resiliency as well as best performance. And of course, faster rebuild times. Okay, ladies and gentlemen, do you have any additional questions? Okay, thank you for your time today and have a good one. Okay, bye bye.